This is a tutorial of Mechanix, a free body diagram tutoring software created by the Sketch Recognition Lab and the iDream Lab at Texas A&M University. We have logged in, and this is instructor mode. We're creating a new problem. We pasted the question text. To add an image, go to Tools, New Image, select the image you want. Clicking on the image enlarges it. Now we draw the truss. You can draw the truss however you'd like. To save time, we'll let the program label it for us, so right-click on the truss and select Label. Okay, now we'll draw the forces acting on the truss. We label by right-clicking and selecting the T, or by simply left-clicking. As you can see, Mechanix tries to predict what label you want to save time. Every time you draw a force, an answer box shows up at the bottom of the screen. Now we enter the answers in those boxes and select units. Finally, we click the green checkbox to submit this question to the server. We select the section, the name of the assignment, set the due date, and add a description, and submit. It was submitted successfully. Now we'll test it in student mode. So we open the client, log in. We'll select the assignment that we just created. Now we'll draw the truss. If the nodes pop up, we know it was recognized correctly. And there they are. So we'll draw the axis. We'll click the green check mark to see if we're on the right track. And we are, and we unlocked a new section of the checklist. So now we'll add input forces as the checklist scaffolding says to. We'll check again. And great, we're ready to move on to reaction forces. So we'll draw those, starting with RAX. Oops, that's supposed to be RAY. And now RCY. We'll enter our calculated answers in the boxes, select units, and we'll check again. Oh, we had the wrong units. Let's change that. And it's correct. So now we're going to make a non-truss free body diagram problem. We've pasted the question text. We're selecting an image. Now we're going to draw the body. In this case, it's a box. The little dots that we're drawing now are nodes. We'll label them. This one's S. Now we draw all the forces. We start with FT, FW, RY, and FF. These are all given in the problem statement above. We're going to enter the values at the bottom of the screen for FF and RY. And then we're going to push the checkbox to submit it to the server. Fill in the information about the assignment, and success. Now we've opened the question in student mode. We're going to draw a body, but that's not the right one. The nodes didn't pop up, so we're going to draw it again. We're drawing the box, and it recognized. You can see the nodes. So we'll draw the forces and label them. Now we're going to check to see if we're on the right track. Oops, we named the force wrong. Let's fix that. Change it to RY. Now we're on the right track. We have to enter the values. Now it's correct. Now this is creative response mode, and we're going to pull over the list, and in this question we want the students to enter the reaction forces, work with a given max tension strength, and use a max of 10 beams. We want to support a minimum weight of 10 newtons. Now we're submitting the question to the server. entering assignment information, and successful. Awesome. Now let's test it in student mode. We will draw the truss, let the program auto-label for us, add the reaction forces, and check. Oops, we forgot to draw an axis, so we'll check again. And to label beams inside the truss, you go to Tools, click Enable Individual Selection. Now the beams within the truss will highlight individually. To label a beam, you label it just like you would any force. For this problem, we're solving for a minimum load, so the input force must be in terms of P, and all resulting equations and forces must also be solved in terms of P. The next truss solves the exact same question, but is a different design, which proves that any answer can be correct as long as it complies to the constraints. Yeah. This last example shows how P can be distributed across the truss. So that's our Mechanix software. Thanks everyone for watching.